Hello everyone, welcome back to another video from the Winter Forest. Let's continue our leetcode challenge. Today's question is called the H index second. Let's look up that question. Given an array of citations sorted in ascending order, each citation is a non-negative integer of a researcher. Write a function to compute a researcher's H index. Here is the explanation. According to definition of H index on Wikipedia, a scientist has index H if H of his or her own paper have at least H citation each. And the other N minus H papers have no more than H citation each. Okay, and so this question and actually this question as a program is easy. The confusing things in here for me actually hate this definition. I don't really understand when I first saw. So actually I'm looking the Wikipedia. And I'm also looking in a video explain what is H index. And if you are very good, like me, not coming from an English background, one sentence actually not really make sense for me. Basically, simplified, for program, what we going to do, we actually going to looping and find the smallest index H, and where this H plus citation, this what the citation, the H plus this citation. So we find the index, and this index plus these citations, this H need a great and equal to n. So that is the goal. So if we found this H, if the H is founded, if found, so then return n minus H. Now our goal just write a loop. We have a sorted array. The best way it is write a binary search. And in here, he also give a hint to runtime complexity is O log n. But I'm going to use both linear search and binary search, because the linear search more explain what going on in here, and the binary search is the optimize to make sure the time complexity it is O log n. And now we first do linear search. So first we have the n it is the citation dot length. Now we just need to find the H. By default is 0. If we find, we just return n minus H. If we don't find it, so the H still is 0. And then we have the while loop. The H, like I said, if the H small, make sure we didn't out of range. So if the H smaller than n, and it is this condition, and the n is greater than citation plus H. So we're going to find if it is great, means we need to continue looping. So the H plus plus, because we start with a 0. So until if you found it, if you didn't find it, it definitely you're going to looping from everybody. You're going to the last one. Otherwise, you're going to find it. For this example, linear search probably is not sorted array. You're going to loop everybody, and this citation not big. It definitely is fine. And now we just submit it. We could test, make sure I don't have a syntax issue. Look like a fun. Submit it. It's running. and it's accepted. Now we're going to optimize it. And so because it is a sorted array, so instead of just from left to the right, we actually just cut to half, and half we just found the hedge actually is our middle. So it actually, boundary research, this is just like a pattern. So we're going to have a left equal to 0, and the right equal to the last item in this citation. So it is the length minus 1. And now we have the n, it is this citation dot length. Suppose just here. Find the n, then find the I, never mind. And now we're going to have a while loop, L smaller equal than right. So until we looping finish. Once we looping finish, the L going to update it. Remember this one, this is just a pattern. Boundary researching, you definitely have this pattern. Now in here, inside you have the middle. Normally you say middle. In here, we're going to find the hedge. So the left plus right minus left, and you're going to divide the 2. So you find the middle. If this is too big, citations. If a citation h too big, actually need to use plus. If this one too big, you could put this on the right side. Actually, if this too big, you actually move the right. Okay. Else you move the left. Boundary research, normally this hedge actually is the middle. So in here, because we found the hedge, defined the middle is a hedge, so we just move the middle to move the right to the middle minus 1. And if too small, move the left to the middle plus 1. And now we run to make sure I didn't have a syntax issue. Okay, it's fine. It is fine. Never mind. Let's submit it. The green tools. Yeah, it also accepted. Thank you for watching. Bye.